Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 2, Section 7, titled Using Measures of Central Tendency. By the end of this video, you will have reviewed methods for finding the measures of central tendency of a data set, mean, median, and mode. Included are solving equations to find missing set member values, finding the range of a set of data values, and creating and using stem and leaf plots. Additionally, you will review skills for solving real-world central tendency problems. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find the video to be helpful. Thank you. So before we get started, let's look at a few definitions. We'll go over them again later in the video, but let's just get them in our mind to start thinking about them. Measures of central tendency. Mean, median, and mode are the measures of central tendency. We'll discuss how to use them shortly. Range. The range of a set of data is the difference between the greatest and least value. Okay? So basically, it's a subtraction problem. You take the greatest value and subtract the smallest value. Stem and leaf plot. A stem and leaf plot is a display of data made by using the digits of the values. And an outlier is a data value that is either much less or much greater than the other members of the data set. We'll look at those too. Okay, objective 1, finding mean, median, and mode. To understand a set of data, you need to organize and summarize the data using measures of central tendency. They are the mean, median, mode, and they are all measures of central tendency. You must decide which measure of central tendency best describes your set of data. Below is a review of mean, median, and mode, and where you should use each as a measure of central tendency. So let's look at these. We've got this chart here. So it says mean. The mean is the sum, right here, the sum of the data digits, data items. I'm going to change colors here. Let's go with blue. It's the sum of the data items divided by the number of data items. Use the mean to describe the middle of a set of data that does not have an outlier. And we'll talk about an outlier. An outlier is a data value that is much higher or lower than the other data values in the set. The mean is often referred to as the average. So if I asked you to give me the average of the numbers 1, 2, and 3, what would you do? You would add these three figures together. So you get 1 plus 2 is 3 plus 3 is 6. That equals 6, and there are 3 items. You divide by 3, and then that would be equal to 2. So the average of 1, 2, and 3 is 2, and it's kind of easy to see. You can see the 2 is right here in the middle. It's not quite as easy if there was an even number like 1, 2, 3, and 4. Then 1, 2, 3, and 4 gives you a 10, and 10 divided by now 4 is equal to 2.5, right? So you can see that it would be right here in the middle of 2.5. Okay, so it talks about an outlier. What's an outlier? How about this? 1, 2, 3, 4, and 10. Well, 10's an outlier. It's way out from the group. And what it's going to do is if you try to take the average, it's going to want to shift your average value to the right in this case toward the 10, which really most of your data is 1, 2, 3, 4 is down in this lower range. The 10 kind of throws it off. Or it makes it look higher than it truly is, because this would be 20 divided by 5, which would be 4. Or if you throw out that 10, it's going to, the average, we did it already, is going to be 2.5. Oftentimes you'll find as you get using these is they often throw out, when we're doing tests, we throw out the outliers because they interfere with the test. The median is right here, the median. Right, where are we? Here we are, median. The median is the middle value in a set when the numbers are arranged in order. For a set containing an even number of data items, the median is the mean of the two middle values. So it's almost like what we showed right here when we looked at the this average, right? 2 and 3, if you 2 plus 3 is 5, and half of 5 is 2.5. So it's kind of the same thing they're talking about. So if your numbers were 1, 3, 5, 6, 8, 9, and 11, 1, 2, 3, 4, 5, 6, 7, then in this case, the median would be the middle value. 1, 2, 3, the 6 is the median value in this case. But if we had another value in here, 12, then there's 1, 2, 3, 4, 5, 6, 7, 8. So that means there's 1, 2, 3, 4, the middle, 1, 2, 3, 4. There's no middle value. So what do? You take the 8 and the 6 and you add them together and divide by 2. So 8 and 6, the number in here is going to be a 7, right? So that the median is going to equal 7 with this 12 added on here, where before it was 6. Okay, and then finally the mode. Okay, use the median to describe the middle of a set of data that does not have an outlier. Again, if you have an outlier, usually we end up throwing those away. Well, unless your teacher, as you're in school, unless your teacher wants you to account for everything or tells you to get rid of outliers. That's kind of up to your teacher or instructor. The mode right here, the mode is the data item that occurs most often. It is possible for a set of data to have no mode, one mode, or more than one mode. So let's look at it. For mode, 1, 2, 2, 2, 3, 4, 5, 5, 6, 7, 7, 7. How's that? These are all separate numbers. So the mode would be, it says the data that occurs most often. Well, in this particular set, if this set stopped right here at the 6, say, and it didn't run these 7s here at the end, these 7s were not included, you'd have 2, 2, 2, 3, 4, 5, 5, and a 6. Well, there are 3 2s. So in this case, the mode would be equal to 2, because that's the most number in occur. There's more 5s than some of the other ones, but it's still not the most. But if we erase this here and allowed the 777 to come into our data set, then we'd have a mode of 2, and we'd have a mode of 7. They're equal. 3 2s, 3 7s. If there were 4 7s all of a sudden, then the 2 wouldn't be a part of the mode anymore. We use the mode when the data are non-numeric or when choosing the most popular item. Okay, like how many students read a certain book for the summer reading program. Some students, half of the students might have read one particular book, plus some others, and all the rest of the books are read maybe one, whatever. You get the idea. So it depends on how many times the book was read. Could be the mode of the summer reading program for the mode in terms of books. Anyways, we'll move on and we'll look at more of these. Okay, example 1, the real-world problem solving. Find the mean, median, and mode of the data in the line plot below. Which measure of central tendency best describes the data? Okay, so if we look at it here, we see it's a cafe, and the cafe in the heading here says hourly wages of employees at a local restaurant. So what do we see? We see a number line, so to speak. We have 6.25, 6.50, 6.75, $7. These are all wages per hour. And the X's, there's an X for every employee. So in this case, there are 1, 2, 3, 4, 5 employees making $6.25. 1, 2, 3 making $6.50, one making $7, and one making $8.25. So they want to know the mean. So what do? To get the mean, we have to add up all of the wages and then divide by the number of employees. Well, if we do that, we're going to come up with 625 times 5 is going to be 30. I'm going to write it over down here. It's 31.25. 650 times 3 is going to be 18 plus $1.50 is 19.50. Okay, and then there's one for $7 and one for $8.25. Okay, when you add these up, we get 5, 5 is 10. Carry the 1, we get 8, and 2 is 10. Carry the 1, this is 9, 10, 11, 18, and 8, okay, is 26. Down the 6, carry the 2, 2, 3, and 1 is 6. So the answer is the total salary is $66 even per hour. And how many employees are there? There are 10. So 66 divided by 10 is equal to 6.6. So what do we get? We get right here, you see it, that the mean, the average, or the mean is called the average sometimes, is the, on average, you could say, an employee will be making $6.60 at this cafe. Okay. And the median, what is the median? The median is a little different. The median is the middle value. All you want to know is what is the exact middle value? If it's an odd number, if there are an odd number of values, it is exactly the middle number. If there are even number of values, then it's the middle two added together and divided by 2. You take the average of the two. So let's look at this. We have 625 times 5, and then you have a 650. 650 is 7, and an 825. So how many? That's 10, we know, right? So there's 1, 2, 3, 4, 5. They have these two red ones right here, so you can kind of see that in this case, and we on this side we have 1, 2, 3, 4, 5. So it's an even number. So that means we're going to have to take the middle two values, add them together. 625 and 650 is 1275, and divide by 2. And it's right here. 625 plus 650 divided by 2 is $6.37.5. That's the median value. The exact middle value. That means half the people are making less than that, and half of them are making more than that. Okay. And then the mode is the value that happens the most frequently. And in our case, it's easy to see because of this line plot. The value that happened most frequently happens to be the 625. So 5 people, half of the people are right at the minimum wage here in this chart. And that ends up being the mode. 625 is the mode. That's the data item that occurs most often. And I'm reading down here at the bottom, it says the mean is 660. We determined that right here, 660. The median is about $6.38. What was it? 6.375, I think is what it was. And the mode is 625. That's the one that happens the most often. The mean is greater than the salary of 8 of the workers. So that when the mean is way out here at 660, I mean, 8 people make less than 660. So it's not a very good representation of the salary paid or paid to the workers at this through this chart. Then it says the that's the mean. The what do we have? The median is 638. That's above almost. It's kind of well, it's kind of right in it's above the lowest, but not above the second highest. But it's kind of surrounded pretty much by the data values that are most common. And the mode of the salary workers is the lowest salary, which is 625. So it doesn't help to talk about what the lowest pay is when you have 5 more people making more than that. So the best central tendency item is the median. It best describes the data because it sits here. We're going to draw a picture of it. It sits right, if you wanted to put a line where it is, it's $6.38. Here's 650. 638 is probably right about where these dots are. So it's closer to the 650 than the 625, I think. Maybe not even by much. But anyways, you can see that it's kind of centralizes the data. It's just these two values way up here that are outliers. But you can kind of tell from this line right here that that's pretty much a good representation of the employee's salary. Okay, example 1, check your understanding. So as you know from working with me, it's time for you to stop the video and try this on your own. I've given you enough help here. I said solve using the data. I repeated the data from the slide before because that's what they want us to be using here, except for the change outlined in part A. I've included the change in your data already. So go ahead and stop the video and try this. See if you can come up with what's asked for here. And when you come back, we'll do it together. Okay? Okay, I'm assuming you've done that and you've got a good answer for it. And it came pretty straightforward for you. So let's do it. They want, and the employee that earns 8.25 per hour resigns. And she is replaced with an employee that earns 7.50 per hour. So that means that her outlier from previously is no, not as much of an outlier as it used to be. It's closer in. It's closer to the $7 one, right? Anyways, so then it says she's now paid 7.50 per hour. Find the mean, the median, and the mode of the data. So this is the same problem we just had, but let's go ahead and do it again. But now we're going to change one value, and the value we're going to change is this one right here, the 7.50. We're going to use, instead of 8.25, we're going to use 7.50, and then we're just going to come up with new numbers. So let's see what they are. So if I do 6, again, 5 times 625, we know that, right? It was 31.25. And then the 650 times 3 was a 19.50. And we have a 7 and a 7.50. Well, that's 14, right? 7 and 7.50 is 14.50. So I'm just going to write 14.50. Make this math go a little easier. And when I do that, I've got $1.25. So here I've got 25, and I'm going to add the dollar up here. So 9, 10, 11, 15. Carry the 1, 5, 6. Okay. So that's these three. Now we're going to add, oh no, that's added, everything's in. So $65.25. So the new wage now, so they want us to find the mean, median, and mode. The mean is 665, right? 65.25. We're going to divide that by 10. So 65.25 divided by 10 is equal to 6.53. And I can put dollars on here if you want. So that's the mean. Okay, now what's the mode? We can go back to here. The mode is which, if we stretch this line out, or the median they want right now. That's the, excuse me, the median is the, we know the mode, right? The mode hasn't changed. It's right here. So the mode, let's get it in here. MODE is equal to 625. Certainly happens the most times right here. Then let's go ahead and do now the median. The median is we've got the same number. Same number, so that means we're right in the middle. But and what are we in the middle of? We're in the middle of, let's see, we have 1, 2, 3, 4, 5 of these. 1, 2, 3, 4, 5. So it's 625 and 650. It's the same thing. So the median is equal to 625 plus 650 divided by 2. And that equals what? That's what it equals. So that's 1275 divided by 2 is going to be 6.375. And if you round it, it'd be 6.30 or 638. Okay, $6.38. That didn't change. The only thing that changed is the mean. The mean went to $6.53. Which best describes the data and why? It's the same thing. The median is best described because it's $6.38. It's above the 5 and just barely below the 3. And the two outliers, the 7 and the 750, don't make that much of a difference. Okay. Okay, example 2, solving an equation. Suppose your grades on the your three history exams are 80, 93, and 91. What grade do you need on your next exam to have a 90 average for the 4 exams? Well, they want an average, right? So that we know we're looking for the mean, since they're asking for an average right here, the average, right? So what do? To find the mean, we take our 3 test scores, 80, 93, and 91, add them together, and plus x. So what we get then is 80 plus 93 plus 91 is 264 plus x, the value we don't know. And we know that in order to get the average, we have to divide that by 4. So we're going to divide it by 4. And which score are we looking for? We want 90. We want to be able to know, if it's greater than 90, I guess that's good. We at least a 90, right? So if we solve this, we're going to multiply both sides by 4 to get rid of the 4's. Multiply this side by 4 and this side by 4, the right side by 4. And when you do that, you're going to get 264 plus x is equal to 360. Okay, and now you're going to combine these 264, right? You're going to move the 64. These two combine here to cancel each other out by adding in a negative 264 to both sides, because you have 264 minus 264 plus x is equal to 360 minus 264. You have to subtract 264 from both sides. It's called undoing the subtraction or the addition or whatever it is you want to do here, call it. Okay? This would be undoing the subtraction. And you undo a subtraction by doing an addition. So when you do that, you're going to get x equal to 96. So that is the answer. You need a 96. Your grade on your next exam must be a 96 to have an average of 90. If you had a 97, you'd have higher than 90, right? You'd have 90 and a quarter. Okay, so here we go. Okay, example 2, check your understanding. So it says here, if 100 is the highest score possible on the 4th exam you're going to have, is it possible to raise your score to an average of 92? Well, since I said the average, we know that we are looking for the mean. Now, we're going to be looking for a mean. Okay, it says your past scores were 80, 93, and 100, and 91 rather. That's from the previous slide. So what it's asking then, is it possible to get a 92? How high does your test have to be, the score, to get a 92? Well, let's run the problem and see what it comes up with. Let's see what resolves. So we're going to say we have an 80, plus we have a 93, plus we have a 91, plus we have some unknown value of that score we have to get 92, right? And we know that when we have all these scores, we're going to divide them by 4, because the mean is you add up all the scores and you divide by 4. And that's, these are all one group because of the division line here. So that has to be equal to 92. So what will x have to be for this to be equal, for this equation, this expression to be 92? Well, let's solve it. So we're going to, in order to do that, we're going to multiply both sides by 4 to clear the division on the left-hand side. So we're going to say 4 times, and what is it? Well, I'll just put it all together. So it's 80, 93, and 91. We know from before that that's 264 plus the x divided by the x is equal to 92 times 4, because we had to multiply both sides by 4. And when we do that, these 4's are going to cancel, and we're going to have 264 plus the x, and that's going to be equal to 92 times 4. And 90 times 4 is 360. 2 times 4 is 8, so it's going to be 368. Now we have to get the x by itself, and we're going to have to undo this addition here. But to do that, we're going to use the subtraction property of equality. So we're going to subtract 264 plus 264 plus x, and that equals 368 minus 264. And then when we do that, these two are gonna cancel, and we're gonna have x is equal to what? 104. So the answer is you have to be able to get a 104 on your final test in order to get a 92 average. And so the answer is no. You cannot raise your score to 92. The highest you can get is, well, whatever. I don't know what it is offhand, but the answer is no. Is it possible to raise your score? No. Okay, example 3, finding the range and mean of data. The range of a set of data is the difference between the greatest and least data values. The range gives you a measure of how widespread the data is. Your data could be all clumped together, or, in terms of values, or it could be spread out. Okay, so that's kind of what you're trying to get a picture of. So we have two data sets here. Here's this one, the first data set right here, and here's the other second data set right here. And it says find the range and mean of each data set. Use the range to compare the spread of the two sets when we're done. So looking at the one on the left, look for the range. What is the range? It says the greatest, the difference between the greatest and the least. Well, the greatest in our case on this side is 47, and the least happens to be 25. So 47 minus 25 gives us a 22. Let's jump to the other side. So on this other set of data, we have a range. The greatest is 36. As I look over the values, 36 is the highest that goes. And the lowest it goes seems to be this 28. So we're going to have a 36 minus 28, and that's going to give us an 8. So that's the range. So we can see right off the bat that the spread of the data values on the left-hand side is greater than the spread on the right-hand side. So what's the mean? Well, the mean is we're going to add them up. We're going to add 25, 30, 30, 47, and 28 on the one side. And we're going to add on the other 34, 28, 31, 36, and 31. Just take the 5 numbers on each side and add them up independently. Divide them each by 5. So we have 25 plus 30 plus 30 plus 47 plus 28 is equal to 160 divided by 5. 160 divided by 5 is 32. And look at this, it's kind of funny because 34, 28, 31, 36, and 31 also add up to 160. And when you divide by 5, it's 32. But I guess the curious thing here is that the set on the right-hand side with the range of 8, the data is much closer together than on the other ones. Okay, 22 versus 8. So, but the mean is the same, but the range is spread out more. So both sets of data have a mean of 32, and the range of the first set is 22, and the range of the second set is 8. The second set of data is less spread out than the first set of data. Okay, example 3, check your understanding. So as you know, now that you've been working with me here, you know that I'm wanting you to stop the video and try this. Try these, and then when you come back, we'll work them together. I'll read it first. Directions. For the first 5 days in February, the low temperatures in northern Maine were 7 degrees Fahrenheit, 4 degrees, 0 degrees, -3 degrees Fahrenheit, and -6 or -6 degrees Fahrenheit. During that same period of time, the low temperatures in northern Michigan had 24 degrees Fahrenheit, 15 degrees Fahrenheit, -2 degrees Fahrenheit, -5 degrees Fahrenheit, and -10 degrees Fahrenheit. Find the mean and the range of the temperatures and compare the spreads of the data, of the temperature data. So go ahead and stop the video, and when you come back, we'll do these together, okay? Okay, I'm sure you've stopped the video, and I certainly hope you have, because that's how you learn mathematics, by actually doing it. So let's start off with Maine's data. Maine has a 7, a 4, a 0, a -3, and a -6. If we add them, what am I going to get? 7 plus 4 is 11, minus 9 is 2. Okay? 2 divided by 1, 2, 3, 4, 5 data points, because you have to count the 0. It was a day. So 2 divided by 5 is equal to 0.4. Okay? Michigan, 24, 15, -2, -5, and -10. So what does that come out to? So 24 plus 15 is 24, 34, 39. 29 minus the 10 minus 7 is 22. So now we have 22 divided by 5, and that equals 4.4. 22 divided by 5 is 4.4. Okay, so that is what? That is the mean, right? Mean. We added them up and divided. The mean. And they also want to know the range. So what is the range of the main data? The main data, the largest number is 7 minus what? The lowest number is -6. The lowest number minus -6. That equals 13 is the range. Range. How about Michigan? The highest value, 24, they're in order. I have them 24 minus -10. That equals 34 is the range. So the spread is almost 3 times as much of the data points, much wider range. So Maine's weather was more similar every day. Ours here in Michigan, us particularly in northern Michigan, that's where we're coming from, is spread out farther. Okay, objective 2A, stem and leaf plots. It's one of the things we said we were going to talk about, stem and leaf, and then how to design them and how to build them and use them. So you can use a stem and leaf plot to organize your data. A stem and leaf plot is a display of the data made by using the digits of the values. To make a stem and leaf plot, you separate each number into a stem and a leaf. And below here, this is the stem and leaf for the number 1.54. So when we do that, all the digits to the left of the last digit. So here we're looking at the last digit. This is called, the last digit's called the leaf. And the stem are all the digits before it. So what you're going to have is you use the least significant digit, which is the last digit. So you got 1.54, could be 2.36, whatever the number, you're going to use the same range of data for the leaf, right? So in this case, 1.5 is the stem and 4 is the leaf. So let's go on and see how this looks, how it works. So example 4, making a stem and leaf plot. Make a stem and leaf plot for the data at the right. So we have a gas pump, right? And they're showing us the gasoline prices, cost per gallon. So we have $1.77. I'm going to change this to red, I think. $1.77, $1.55, so you can see the values. So, and they're pretty much like the values that we just looked at. So we're going to use to make the stem, the stem is going to be the first two right here, right? And then the leaf will be this last one, right? Of all of these values. And we don't have to worry about the order of the data, but they'll be ordered when we put them in the plot. So to make the plot, you see that we're going to have, there's a line that goes right down the middle here, this line. Okay, that line right there. That splits the stem, which is on this side, and the leaf, and there's more than one leaf. Okay, so so all the stem values of 1.5 could be 1.54, 1.55, 1.58, 1.51, 1.50. Okay, so the stem is the first to the 10-cent mark, right? And then everything below that is going to be the one item. But for all the values, you're going to keep putting them in. So let's take a look at it. So we have the very first one. Well, you see that we have what is the lowest value? The lowest value is $1.54. $1.54. Here's the lowest value. So it's 1.5. What's the highest value? 1.6, 1.8. There are no 1.9s. So the highest value is 1.9 and 1.8. There's only 1.8. So it's this one here, 1.83. So we're going to go from 1.5. Here's our 1.5 value, and our 1.8 value is down here. So now we're going to put in all of the hundreds, the pennies. So for $1.5 with pennies, right? $1.54, $1.55. So we have a 54. We put a 4 here. Okay, and they go in order. You go in order from the stem out. Okay, always from the stem out. So you have to look at them. You don't just write them in order. We find that the next one's a 5. 155. Is there another 55? No. Is there a 56, 57? Which one we look? 58? Yes, there's a 58. Right here, 58. So we put the 8. So now we have a 4, a 5, and an 8 for the $1.50 somethings. $1.54, $1.55, $1.58. Then we don't have any more 50s. We're going to go to the $1.60s. And we have a $1.63 right here. And we have a $1.67. So we put in the 3 in order. The 3, then the 7. Then we do, what's next? We have to go to the 70s. So $1.73. I don't see anything lower, and 77. There's no other 70s. So again, 3 and the 7, moving from left to right. In the future, we're going to be working with 2 columns, 2 lines up and down the center here. And then when you're working on the left-hand side, you'll go from inner to the outer same way, only it's going in the other direction. You'll see it when we get there. And then finally at the end, there's a $1.80 something. It's a $1.83 right there, that one. So we put the 183. So here's our stem and leaf. And so they're giving you an example of the 1.83 means $1.83. So that's the stem and leaf plot. So now that you know that there were 3 values that were in the 150 range, 2 in the 160 and 170 range, and 1 value in the 180 range. Okay? Okay, example 4, check your understanding. Make a stem and leaf plot for the data below. So you know that I'm just asking you to stop the video and try it, see how it turns out. And when you come back, we'll work it together. Okay? I'll wait for you. I'll give you a few seconds to stop the video here. Okay, now I'm sure you've done this, so let's give it a shot. So remember, you take the stems and the leaves. So we can do the stems first, or you can do them all at the same time. We'll do the stems. I see there's a 0 in the beginning. So there's one of them, a 1. There's a 2, a 3. There's a 4. There are no 5s for the stems. And there's a 6 right here, 6. So we're going to start off with a 0. We have a 0, a 1, a 2, 3, 4, and a 6. And then when we do this for 0, we have a 0.8, a 0.2, and an 8. So we have a 2, and an 8, and an 8. Remember, this is 0.2, right? 0.8. That's what we have here. How about for the 1? There's a 1.4, no others. 1.4. 2s, we have a 2, 6. I don't see any other 2s. 2, 6. 2.6 right there. How about the 3s? We have a 3.5. Nope, no others. 3.5. How about the 4? 4, 5, 4, 3, 4, 3. So we have 2 4 3s, a 4, 3, another 4, 3, and a 5, 4, 5. 4.3, 4.3, and a 4.5. 3 values. Just like the 0 value up here, there are 3 values. And there's no 5s. So we left it out. The 5 is left out. And then we have a 6.0. 6. Oops, sorry. I'm getting carried away with my writing. And then we have a 6. Oh, still the eraser. 6.0. Okay, so that's it. Each one gets a value in there. There are no 5-point values, but there are 2 zeros, 3 zero values, 0.2, 8, and 8. Then there are 1.4, 1.6, 2.6, 3.5, 4.3, 4.3, and a 4.5, and a 6.0. Okay, objective 2B, stem and leaf plots. You can find the measure of central tendency of a data display in the stem and leaf plot. The stem and leaf plot in the next example is a back-to-back stem and leaf plot. I spoke about that just recently, where you're going to have data for 2 different data sets. In our case, you're going to see it's for city gasoline mileage for a car, city, highway, city, and highway. So we're going to look at data on 2 sides. Okay, the stem between the stem is between the 2 bars. There's going to be 2 vertical bars, and the leaves are on each side. Leaves are increasing in order from the stem, always from the stem out. No matter which direction you're going, stem out. Okay, example 5, using a stem and leaf plot. Find the mean of the city mileage and the highway mileage for 9 new cars. So, as I was saying, you see now that we have we have 2 columns right here. I'm going to change this to red. We have 2 lines, 1 stem, and we have leaves on both sides. They go from smaller to larger from the stem out, right? From the stem on the highway side here, 0, 0, 2, 2, 7, 8, 8, they go out to the right. On the other side, on the left side, they go from, like this case, 1, 1, 4, they go from the stem out to the left. Okay, that's how they go. That's how they work. And you'll see why when we get around to trying to find the median. Okay. So, so now it says, find the median of the city mileage and the highway mileage for 9 new cars. So here's the values, and we've got them. So these are the cars. We have one, it has a city mileage of 19, right here. The city mileage for the first car is 19. Then the next car that they had was a 20 miles per gallon and a 23 miles per gallon, 23 miles per gallon. That's 2 cars with 23, a 28 mile per gallon car and a 29 mile per gallon car. They had a 31 mile per gallon, another 31 mile, and a 34 miles per gallon. Okay, that was the highest that went for the city driving was 34 miles per gallon. For the highway, there was nothing in the teens. In a highway, you could see that they got better gas mileage. That was 28, 27 miles per gallon and 28 miles per gallon. We had a 30 mile per gallon, a 32, a 32, a 37 right there, a 38, and a 38 miles per gallon car, and one 41 miles per gallon car. So as you see here, the mean 20 miles per gallon, okay, is 20. They wrote it down here. The 20 is the mean. And for the highway, it's 27, 27 miles per gallon. Okay, so city mileage. We take the values. Here they are: 19, 20, 23, 23, 28, 29, 31, 31, 34. You can see them, they all, here are they 34, 31, 31, 34, started with a 19. Here's our city miles. We add all of those up, we come up with 26.4 miles per gallon. Add them up and divide by 9. Get 26.4 miles per gallon. For the mean highway mileage, is you take all the highways. We have a 27, a 28. Here's 27, 28. And we have a 30. Right here's the 30, the 32, 32, 37, 38, 37, 38, 38, and a 41. You add them all up and divide by 9, and you get 33.6. Actually, it's 33.666666 miles per gallon, just like the upper one was 26.444444 forever miles per gallon. Okay, so that's using the stem and leaf to come up with the mean, and that type of thing. Okay. Okay, example 5, checking your understanding. So you know that I'm going to ask you to pause the video and try to answer these 3 questions. Find the median of the city mileage and the highway mileage. Find the mode or modes of the city mileage and the highway mileage. And then finally find the range of the city mileage and the highway mileage. We're going to use the same data from the previous slide, so you should be familiar with it and how to read the data. So why don't you go ahead and stop the video and try it. And when you come back, we'll work together on it. Okay, I'm assuming you've stopped it and you've got your answers, and we'll get started on it. First thing I'm going to say, just to put this all to rest, how many values are there? Remember, there were 9 new cars. And if we look at it, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 cars. So that if I look at that, 1, 2, 3, 4, 5, 6, 7, 8, 9. Since there's 9 cars, there's an odd number of cars, and that means there's going to be one value exactly right here in the middle that is the mode number, right? 5 is the 5th term. The 5th one is not the mode, excuse me, is the median value. If it were 10 or 8, we'd had to like split half the distance between, right? If there were 10 values, 5 plus 6 divided by 2 would have been the answer, 5.5. So let's go on with our problem here. Find the median of the city mileage and the highway mileage. So I'll say the city, I'll use the C for the city and an H for the highway. So the median of the city mileage is the middle, the 5th term. So it's 19, 20, 21, 22, right? 28. That is the median of the city. So it's 28. Right? And then for the highway, it's 27, 28, 30, 32, and 32. This one right here is the median. 1, 2, 3, 4 below it. 1, 2, 3, 4 above it. I'll do it. See, 1, 2, 3, 4 vehicles below. 7, 8, 8, and the 41 makes 4 above. So it's 32. 32 is the highway. There's the median of those two. So find the mode or modes of the city and highway mileage. So the modes are, if you remember, you can have no modes, you can have one mode, you can have 2 or more modes, depending on how many terms you have. But the mode is the value that occurs the most often. Okay. And if there are 2 so if it's a tie, so to speak, if there are 3 values that occur the same value, then you're going to have 3 different modes maybe. So let's look at these. Um, so if I'm looking at the city, so we're going to have city and highway again. So for the city, I see 3s here and 1s. So that means that 23s are modes. So we have 23s, 23 and a 23. Okay, and 31s. The ones are modes, so those are 31s. And 31 and 31. Those are the modes, right? These 2 here, 31s and 23s. Maybe I could I'll make it a little cleaner. How about if I get rid of this, and I'm just going to write one value, not all of them. I'm just going to say, how about if it's 23 and 31? There's two of each, and those are mode. 23 is a mode, and 31 is a mode. For the highway, we have 32s. There's two 32s, two 38s. Now we can't count that 8 with the 28 because that's a different value. That just happens to be an 8, but it's not 28. It's 38 we're looking for, or it is 28. We're looking for 38s in this case because there's already two 38s. So the highway is going to be 32, 32, and 38. 38. Those are the highway modes. There's two of them. If there were three, if there was another 8 over here, put another 8 over here, that'd been three 38s. Well, guess what? Then the 32s would not have been a mode. The 8s would have been a mode all by themselves. So not a very good 8. Okay, so now find the range. The range is literally just subtract the highest from the least. So for the city, it's 34 minus 19. And we do that, that's going to be equal to 15. So this is the city, okay? And for the highway is equal to 41 minus 27. And 41 minus 27 is 14. So city is 15 and the highway is 14. That is the range. They're close to the same. The spread is close to the same, highway and city, right? In terms of the distance between them. Okay. So it kind of makes sense then if you get the low mileage and the high mileage, they should be a pretty close spread. Shouldn't see a big jump, right? You shouldn't see a big jump anywhere. They all should be kind of common. Okay, there it is.